Okay, we're going to talk about sets. Sets are just groups. In math, they're just sets. They're just groups. Lesson 5. Sets and set notation. Let's say A is the set 1, 2, 3, 4, and 5. Okay, so this set is notated by these braces, right? And then these guys, what are these guys called? Do you know what these guys are called? Any guesses?
Numbers?
There are 5 numbers. So what did you say numbers?
I said prime numbers.
Yeah, some of them are prime. But these are called the elements or the members. Elements or members of the sets, of the set, okay? So A is the set name. 1, 2, 3, 4, and 5 are the 5 members or 5 elements of this set, okay? So if I were to say this in English, it would be A is a set whose numbers, whose members are, you could say counting numbers 1 through 5. So that'd be a good way to describe it. Okay, so those are sets. Now there are certain subsets of the real numbers. We've talked a little bit about this, but counting numbers, the full complete set of counting numbers, or remember the other name for counting numbers are natural numbers. Start with 1, 2, 3, and then you go on in that pattern. So there's an infinite number of counting numbers. So counting numbers, in short, are numbers you count with. You don't start with 0, 1, 2, right? Ethan's still a person, so 1, 2, 3. And you don't say 1, 1.5, 1 3/4. No, that's offensive if you count like that, okay? So 1, 2, 3, 4. No fractions in between, no zeros. There is a set that includes the 0, and that's the whole numbers, right? A good way to remember it is, what's the difference between counting numbers and whole numbers? Whole numbers have a 0 or a hole in it, okay? So far so good? And then we've got another one, still no fractions. And this one is still no fractions. Integers are all the negative numbers. Not all the negative numbers, just the opposite of the whole numbers or counting numbers. And they've got that 0 in there as well. So a lazy way to define integers are all the whole numbers and their opposites. I say lazy because 0 doesn't have an opposite. But it's easier to say that than all the counting numbers and their opposites and 0. Okay? So if I say integers are all the whole numbers and their opposites, it kind of overlaps a little bit because 0 doesn't have an opposite, but it's easier to say that. So integers are all the whole numbers and their opposites, but still nothing in between. No fractions. Okay? So all these numbers, and I think we talked about this, the negative numbers were like blasphemous to the ancients. So, but because negative numbers really still have a value, they still have a bigness to it. -3 is farther away than -2. So, absolute value, this is hard to define, but the best way to define it is the distance from 0. But basically, how do you apply absolute value? You just take away the sign. If it's positive, leave it positive. If it's negative, then make it positive. So this is distance from 0, or the origin. So for example, absolute value of -3/4 is just 3/4. Take away the sign. absolute value of negative 7.12 is 7.12. Okay? It gets trickier when you throw a negative sign in front of the absolute value. Well, you have to do the absolute value first and then the negatives, because absolute values symbols, these are a type of what we would call parentheses or symbols of inclusion. These are like parentheses. They are a symbol of inclusion, so you have to do that first. Okay, so do this first. So after you do that first, you're left with negative, and then 20 minus 2 is 18. So here's your answer. So don't be weirded out by this. Even though this is an absolute value problem, your answer is still negative because the absolute value problem was nested or inside this overall problem. So when you put a negative sign on the outside of an absolute value problem, your answer will always be negative, right? Because this will always be positive. So if I do this, negative 2 minus 20, then it's negative absolute value of negative 18. Well, absolute value of negative 18 is 18, so it's just negative 18. So these two have the same answer. Okay, so here's a problem, and here's a problem. They both have the same answer. Okay, so this is the only thing that might confuse you with absolute value, is if there's stuff happening outside the absolute value sign. So far, so good? Okay, there's a little bit more to lesson 5. Okay, so this is just addition of sign numbers. Now your book is probably going to suggest doing this a certain way. You just do it whatever works, okay? And addition of sign numbers could be tricky on a calculator, so let's try to remember how to do this without a calculator first. So on a number line, if I was saying 3 plus negative 2, I would go right 3, left 2. Okay, so I'd go 1, 2, 3 to the right, and then I'd go 2 to the left, and I'd end up at positive 1, right? And 3 minus 2 obviously means the same thing. When you're subtracting, you just go left. So this is, your book might say use a number line to describe this problem. You don't have to. You can just add it. All right? Okay, so negative 5 plus 3, you can use a number line if you want, but can you do this in your head? What's negative 5 plus 3? Negative 2, that's right. So you could go left 5 on the number line, 1, 2, 3, 4, 5, and then right 3, and then you end up at negative 2 there. You could do it that way if you wanted to. The way I always like to do it is you have opposite signs adding. So these are like opposite armies. So the negative army has 5 in it, the positive army has 3 in it. When they fight, who's going to win? The negative army. So they're going to have the negative army will have 2 left on the battlefield because everyone else is dead. Apparently that's what happens in battle. Like, I guess, yeah, nobody wins. Nobody wins with the headbutt either. Yes?
Why can't they just be knocked unconscious?
They could. Okay, let's do that. That's the homeschool version. That feels better. That's good. Okay, so negative 2 when they fight. So conflicting signs, these guys don't like each other, so they're going to fight. But if you have the same sign, -5 plus -3, when they go down to the battlefield, what happens? They join forces. So now it's a bigger negative army.
Attention teachers and students. Please, all 8th graders come down for pictures. All 8th graders that haven't had their pictures taken come down for pictures. Teachers, if you need a sub, call 1-2.
Are anyone else 8th grade? Okay, good luck. Smile. Okay, almost done with 5 here. So then you can put them together. Let's say all these armies go down to the battlefield. -4 plus +2 plus -1 plus +5. Can you guys do this in your head? What is it? +2. Is that what you guys got? So how'd you do that so quickly? Ow.
4 and 1 = 5.
Yeah, so that negative, that's a -5, and then you saw that 5 and those canceled, and this is what you're left with. Okay, good. So you can look for those patterns that will cancel each other out. That's a great way to do that. What I typically do if I don't see patterns is I'll just combine. So if these guys show up on the battlefield, this army's gonna go, oh, excuse me, I'm gonna go join my friends over here, and then I'm gonna kill you. Okay? So let the negative armies join up, let the positive armies join up, and then let them fight. Well, positive was a win. Okay? Does that feel all right? Can you guys do that? If you need to use a little Skittles or M&Ms. Did anyone play Risk? I think we talked about this last year. If you've played Risk, you know, like if the odds were exactly even and fair, then every time, like the blue would win, the red would win. So if the blue had 43 on their country and the red had 30 on their country, then if they went back and forth and the dice were rolled evenly, then the blue would win by 13 blues. Okay, so it's a good game. It's a very potentially long game, but it's a good game. All right, that's lesson 5.
Flack math, give me some math and I'll give you some flack. Flack math.